Hi, I'm Eric from Kibsi, and welcome to our Getting Started series. In this video, we're going to take what we built in our Hello World video and some of the ideas we shared in our Core Concepts video and put them together to build a real Kibsi application. But this time, we're going to build something a little more complex to learn a little more about Kibsi and produce a more interesting data model from our video stream. Now, this video assumes that you've watched the two videos I just mentioned, so if you haven't had a chance to do that, now's a good time to take a moment, go watch those videos, and then we can jump right in. For the app we're going to build today, we're going to use a different public stream of a busy intersection located on Castro Street in San Francisco. But before we even open up our application designer, let's look at this stream for a moment and think about it as a data model. Remember, the data model is the most important core concept. So instead of thinking about this stream in terms of the individual things that we want to detect, let's think about what this stream would look like if it were converted into structured data. So we've certainly got all kinds of vehicles, cars and trucks. Eventually we might see some buses and motorcycles. So those vehicles are interesting for our data model. We've got no shortage of people. They're walking around on sidewalks, walking on crosswalks. I imagine some of these people will just cross the road wherever they want, whether they're in a crosswalk or not. So jaywalkers are a potentially interesting data point from the aspect of safety. And also along the lines of safety, it would also be interesting to know whenever a pedestrian and a vehicle are in the same crosswalk at the same time, because that means either the pedestrian or the vehicle did something unsafe. We really should never have a pedestrian and a vehicle in the same crosswalk at the same time. And of course, we'll need to detect individual vehicles and people to help produce those data points, but the individual detections really are just a small part of this data model that we want. So now that we've put some thought into our data model, we can log into Kibsi, open up the application designer, and start to build the application that will produce that data model. First, we'll click Create Application, and name our application Intersection Monitor, and click Create. Now let's create our static item types. Remember, static item types are things that we know we don't need to detect because they're always in the frame. First, we'll create a static item type for our road, name it Road, and click Save. Then we'll repeat that for crosswalk and sidewalk item types. Here I'm also using the mouse wheel to zoom in and out in the designer to fit all our items in the designer window. Now let's create our detected item types. We'll click the plus sign, choose detected item, name it pedestrian, use the search dialog to choose the person detector, click next. We can ignore the enhancers here, we don't need them for this app, and then we can click save. Now let's organize our workspace a bit. Then click the plus sign again, choose add a detected item, name it vehicle. Now in this case, we're going to do something really interesting. We're going to use one detected item called vehicle, but then we're going to use 4 different detectors to define it. First, we'll search for the car detector and select it. Then we'll do the same for truck, bus, and motorcycle. And when we're finished, you can see we have one detected item type called vehicle that will detect cars, trucks, buses, and motorcycles with one detector. Now let's pause and look at our data model. At this stage, you can think of these 5 items sort of like tables in a database. So we have 3 tables to represent our road, sidewalk, and crosswalk static items, and 2 tables to represent our pedestrian and vehicle detected items. Now let's create some relationships between our items. On the crosswalk item, click the plus sign and add a relationship attribute. Let's call this first one pedestrians and crosswalk. Target the pedestrian item type, choose proximity, click next, choose bottom for our evaluation position to focus our detection more on the feet of our pedestrians, and then save our relationship. Now let's do the same thing for pedestrians in the sidewalk. On the sidewalk item, click the plus sign and choose relationship. Name it pedestrians in sidewalk. Target the pedestrian item type, choose proximity, click next, choose bottom for our evaluation position, again to focus on the feet, and click save. Now we expect to see vehicles in our road, so let's create that relationship the same way. Click the plus icon, choose relationship, name it vehicles in road, target the vehicle item type, choose proximity, then bottom, then save the relationship. Now, remember in our data model, we wanted to capture conflicts when vehicles and pedestrians are in the sidewalk at the same time, which is unsafe, as well as jaywalkers. That's when a pedestrian is crossing the road but not using the crosswalk, which is also unsafe. So let's create some relationships to ensure our data model is set up to give us that data when it occurs. On our crosswalk, let's create a relationship to capture when a vehicle is in the crosswalk. Call it vehicles in crosswalk, target the vehicle item type, choose proximity and bottom, and hit save. Finally, let's do the same thing on our road item to capture when a pedestrian is in the road outside a crosswalk. Call it pedestrians in road, target the pedestrians item type, choose proximity and bottom, and hit save. Now let's drag our items around and use the mouse wheel to zoom in and out to get our workspace organized. Now we've turned our collection of tables into a relational database with all the relationships we need to capture the data we want. Next, let's add some attributes to our item types. Now, if a table of data consists of rows and columns, you can think about attributes as the columns in our data model, and the individual static items we deploy and the individual detected items that our application detects, those will be the rows in our data model. So let's add a count attribute to our sidewalk item type to count the number of pedestrians detected per minute. Click the plus on the sidewalk item type to add a new attribute. Choose count, name our attribute pedestrians per minute. Target the pedestrians and sidewalk relationship, specify the time interval of 1 minute, and click save. Now let's do exactly the same thing to count the number of pedestrians that use the crosswalk items. Choose the plus on the crosswalk item type to add a new attribute, choose count, name our attribute pedestrians per minute, target the pedestrians and crosswalk relationship, specify the time interval of 1 minute, and click save. Next, let's add some counter attributes to count the number of vehicles that use the road. Click the plus on the road item type to add a new attribute. Choose count, name our attribute vehicles per hour, target the vehicles in road relationship, specify the time interval of 1 hour, and click save. Now remember that our vehicle detected item type will detect cars, trucks, buses, motorcycles, so let's create some counters for those. Again, click the plus sign on the road item to add a new attribute. Choose counter, name it cars per hour, target the vehicles in road relationship, but this time click add a filter. Now click the kel button to use the Kibsi expression language to define a filter expression that will only count cars. To do this, we'll type $REL, which refers to the vehicles in road relationship we specified on the previous step. Then type .type equals car, with car in single quotes in all caps. Now, we're going to be using kel quite a bit in this video to get you familiar with how it's used, and we'll also be doing a full deep dive on kel in a later getting started video. Now go ahead and click Save Expression, specify the time interval of 1 hour, and click Save. Notice that our vehicle item type actually doesn't have an attribute called type yet, but we need that in order for the expression we just wrote to work. So let's add that now. On the vehicle item type, click the plus sign, add a new item class attribute, name it type, and click Save. Now, anytime we reference that type attribute, like we did in our count expression a few moments ago, Kibsi will return the class of the item being detected, in this case, car, truck, bus, or motorcycle. So whenever our type equals car, our count expression will count it. Let's create that same count attribute for trucks. Click the plus sign on the road item to add a new attribute, choose counter, name it trucks per hour, target the vehicles in road relationship, but this time click add filter. Now click the kel button to use the Kibsi expression language to define the expression that will only count trucks. To do this, we'll type $rel again, then type .type equals truck, with truck in single quotes in all caps. Then click Save Expression, specify the time interval of 1 hour, and click Save. Now let's go ahead and repeat that count attribute for buses and motorcycles. Since you've already done it for car and truck, I'll speed up the video here a bit so you don't have to sit through it. Next, let's take a look at some state machine examples. A state machine allows us to define any number of states we expect to see our items in, like pending, in progress, or completed. And we can define whatever states we want, as well as the rules for when to transition to another state. For our intersection data model, we care about when pedestrians or vehicles do something unsafe. So let's create state machines on those item types to reflect those two states. First, on our vehicle item type, click the plus sign, choose state machine, call it safety state. Name our first state safe and click the plus sign to add it to our state machine. Notice the icon on the state indicates that safe is our default state, which we can change to another state if we like. Now let's repeat that to add a state for unsafe. Drag a line from the orange dot on the safe state to the orange dot on the unsafe state. This line makes it possible to transition from the safe to the unsafe state. Now click Add Expression to define the rule that will trigger the transition. Click kel to use the Kibsi expression language. Notice that the available options are suggested below the kel editor. Click the crosswalk option. Start to type pedestrian and notice that pedestrians and crosswalk will autocomplete. So go ahead and click that. Finally, add dot length, open close parentheses, and greater than 0. Since this state machine is on the vehicle item type, this will trigger the state change whenever there are more than 0 pedestrians in the same crosswalk as the vehicle. That is, whenever that kel expression evaluates to true. Once a vehicle transitions to the unsafe state, there is no other state for it to transition to and no rule for it to transition back to safe, so it will remain flagged in the unsafe state for its entire life cycle. Go ahead and click Save Expression, then Save to save the state machine. Now let's do exactly the same thing on our pedestrian item type. Now there are 2 ways a pedestrian can be unsafe. First, they can be in a crosswalk at the same time as a vehicle, or they can be a jaywalker. So we will create our state machine exactly the same way as we did for our vehicle safety state, only this time our kel expression will be different. First, we'll simply type road to refer to the road relationship attribute on the pedestrian item. In kel, if a list is empty, it will return false, and if a list has 1 or more items in it, it will return true. So simply putting road here is saying if the road relationship has a road in it, which means our pedestrian is in a road, then the statement will therefore return true. Now, next type or, so we can include our other unsafe state. Again, notice we get some suggestions below the editor. Choose crosswalk, vehicles and crosswalk. Again, this will return true whenever there are any vehicles in the vehicles and crosswalk relationship we defined earlier, and false whenever there are no vehicles. Now, whenever a pedestrian is in the road or in a crosswalk with a vehicle, the pedestrian will transition from safe to unsafe and remain there for the rest of its life cycle. Go ahead and click Save Expression, then Save to save the state machine. Finally, let's add some events to our application to take some action whenever a crosswalk conflict or a jaywalker is detected in our data model. To do this, first click the plus sign and choose the event item type. Name it conflict and choose the crosswalk item as the source. For the start condition, click kel and enter $source.pedestrians in crosswalk and $source.vehicles in crosswalk. Notice you can use the autocomplete suggestions for most of that expression. Now this expression will trigger the start of the conflict event whenever a pedestrian in the crosswalk relationship and the vehicles in crosswalk relationship are both not empty at the same time. Remember, when a relationship is empty, it returns false, and when it's not empty, it will return true. So when it has 1 or more items in it, it will return true. So if there's a vehicle in the crosswalk and a pedestrian in the crosswalk, then both of these relationships would each have 1 item in them, and the statement effectively evaluates to true and true, which will trigger the event because we have the and operator in there. If either relationship is empty, then that relationship will return false, making the whole expression false and not triggering the start of the event. Before going to the next step, go ahead and highlight and copy the expression you just made, then click Next to define our optional end condition. For this, again, click the kel tab, type not, then paste your previous expression between parentheses. This will effectively end your event whenever the opposite of the start event is true. Now, let's click the boxes to save an image snapshot at the beginning and end of our event. Then click Save to create our conflict event. To trigger an event for our jaywalkers, again, click the plus sign and choose the event item type. Name it jaywalker, choose the road item type as the source. For the start condition, click kel and enter $source.pedestrians in road. This will simply trigger the event whenever the pedestrians in road relationship has 1 or more pedestrians in it and returns true. Like we did before, copy our expression, click Next, and then for our end condition, we can use not, paste our start condition in parentheses. This will trigger whenever the start condition is no longer true, so that is whenever our pedestrians finally get out of the road, and go ahead and save the event. Now we have a complete data model with our top-level static items defined for roads, crosswalks, and sidewalks, detected items for pedestrians and vehicles, which includes 4 different types of vehicles, all the relationships needed for our data model, and quite a few interesting attributes for our data, including counts, types, and state machines. And finally, we have 2 events being triggered whenever we see jaywalkers or conflicts in our data model. So let's go ahead and publish a new version of our application, provide some quick notes for this version, and click Save. Now to deploy our app, click on the Kibsi icon in the upper left corner, then navigate to Sites in the upper right. Click the plus icon to add a new site. Let's name our site San Francisco. Choose PST for the time zone and click Save. Next, we'll add a stream to our site. Do this by clicking Create Stream, name it Castro Street, and provide the URL of our Castro Street live stream, which you can get from the video description below. For our snapshot image, save a screen cap of the video stream to your local computer and browse to upload the snapshot to your stream, then click Create. Finally, to deploy our app, click the Deployments icon in the upper right. Click Add Application, Choose the intersection monitor app that we just created, click Configure Deployment. Choose our most recent version, click Next. Choose our Castro Street stream, click Next. Here, go ahead and define 2 static items each for our road, crosswalk, and sidewalks, and click Create. I like to go ahead and name all the static items at one time here. So name your roads A and B, and do the same for crosswalk and sidewalk. Then for each of the static items, carefully draw the regions you'd like to use. For road A, I'll use the area of road closest to the camera here, being careful not to overlap any sidewalk or crosswalk areas I plan to define here in a moment. For road B, I'll do the same for the far road area. Note that you can click Enter at any time while drawing a region to close the polygon to the first point, as well as the trash can icon to delete a polygon and start over. For crosswalk A, I'll specify the large crosswalk that's closest to the camera, and for crosswalk B, configure the region of the far crosswalk. And for the sidewalks, I'll use the closest sidewalk as sidewalk A, and the sidewalk across the street as sidewalk B. Now that we have names and static regions defined for 2 roads, 2 crosswalks, and 2 sidewalks, we're ready to launch our application. Go ahead and click Launch, then Continue. Now, for this application, I recommend letting the app run for a few hours or even overnight so that you can build up a lot of interesting data for both the live and historical views. But when you do come back to review your data, here's a few things you'll want to check out. First, on the live view, take a look at the Road tab to see the real-time data for vehicles, cars, trucks, buses, and motorcycles per hour for both sections of road, Road A and Road B. On the crosswalk and sidewalk tabs, you'll see pedestrians per minute data for all of our crosswalks and sidewalks. On the pedestrian tab, you'll see every pedestrian detected and their safety state from our state machine attribute. And on the vehicles tab, you'll see every vehicle detected, what kind of vehicle it is, and its safety state as well. And then in the individual events panel up top, you can click on individual conflict and jaywalker events, see a snapshot of the data model at the time of the event, and take a look at the image snapshot from both the start and end of the event. Here's an image of a jaywalker captured by our application. And here's an image of a crosswalk conflict showing a vehicle and a pedestrian in the crosswalk at the same time. Both of these images were captured without having to train any custom models for either scenario and without having to manually scrub through hours of video data to get to the snapshots of our events happening. While you're looking at the live view, go ahead and open the video stream view and click Show Detections. You can also resize and drag the viewer so you can see the detections, the data stream, and the events all happening together in real time. Also, spend some time clicking around on the histogram slices of the history view to see what the real-time data looked like for a particular time range. Again, using the tabs below to drill into the data views for crosswalk, road, sidewalk, pedestrian, and vehicle data. Finally, be sure to check out the visual debugger by clicking the ellipsis next to the deployment name and choose your deployment from the drop-down menu. Here you can get a really good understanding of how Kibsi works under the hood and see the data model expressed in its rawest form, updated in real time. I recommend clicking the copy icon next to the events data and pasting that into a JSON editor. I'll provide a link to one in the video description. Then navigate around the data to find the different item types, relationships, attributes, and events that you configured in your application. This is a great way to get to know your data model and to explore the data in an intuitive way. And that's it for our intersection monitor application. In this video, we took many of the Kibsi core concepts and put them together in a real working Kibsi application that turns a video stream of a busy intersection into useful data, captures data about when vehicles and pedestrians do anything unsafe, as well as image snapshots for those safety events. I've also included some links in the video description for a few other live streams of busy intersections, so you can have some fun configuring those as new streams in Kibsi and deploying your app to see how you can extract exactly the same data model from a completely different stream without any changes to your application. We hope you enjoyed this Getting Started video on Kibsi applications. Be sure to check out the other videos in our Getting Started series. Until next time, I'm Eric Miller from Kibsi, and thanks for watching.